Hi everyone, welcome back again. We're starting today new chapter, new lesson 1 in chapter 17. First, we start with revision to know something we took it before. Classify each as rational, irrational, natural, whole, or an integer. List all that apply. From 1 to 4, 1.5 with negative is which one of these? We found this is rational. The second one, this 14 over 7. We have a simplifying for this. 14 over 7, we can make it as 2 in the simplest form. And 2 is rational, natural, whole, integer at the same time. All of them are the same. We can make it generally as rational. It's also correct. But you have to know the result here too will be anything of this. Now we're going to use something else. Negative 4 root 5. Negative 4 root 5 is irrational number. Why irrational? Why we take it before, but we dealing with this lesson today, inshallah. So this, I give you a small hint for this because the square root of 5 is something not whole, something as a decimal. If I multiply by negative 4, will still as a decimal, and without end mean finite decimal. So this is a rational number. This recurring decimal means here, if we're dealing with this one, negative 1 is a rational number. Here we can consider, because this recurring decimal, as this one. So we can consider this as rational number. Now, how we dealing plus or minus with something like this, rational with irrational, or rational with rational, whatever. So 7 root 2 plus 4 root 2 is, we just add this number together. This as a coefficient for you. So 4 plus 7 equals 11 root 2. Here we have to simplify this. If you remember, we try to find something. Two parts of this something is 32. Suppose one of them, suppose we has a square root. So 32 we can consider as 16 times 2. So we can consider 32 as 16 times 2. And 16 has two parts. 16 times 2 equals 32. 16 has a square root, is 4. And 2 has no square root. So this number consists of two parts. 16, 2. 16 will be 4. 4 times 2, 8. So this will be 8 because we have here 16 times the square root of 16 is 4 times 2 is 8. And we still with us here 2 because 16 times 2. So will be 8 root 2. 8 root 2 plus 2 root 2 is 10 root 2. I think something old we remember a little bit. Objective. Now we have to how to dealing with the operation with rational and irrational in this chapter. So how do you know when operation with rational and irrational number result in an irrational number? We don't know yet, we will know. So we have to remember this diagram. Help me to remember the first kind of numbers we take it together is natural number. Is 1 2 3 4, all your numbers from 1 up to infinity, or from 0 to infinity. This is your whole number. We call this sometimes whole number, starting from 0. Sum of books or sum of material. Told you natural number starts with 0 is also correct, but you have to know the whole number starts with 0, or natural number here consists of all number without negative. Now we're going to the integer number. Integer number, anything with negative. And anything like this form is negative, but whole number. So negative 8 over 4 equals negative 2, and negative 16. So all of these are whole numbers, and they are negative. So anything was positive or negative, they are integers. And supposed to be whole number, meaning number like this. Rational number. Rational number here mean any fraction. Any fraction. So the rational number, any fraction like this, 1 over 2. Numerator and denominator. This I told we know to convert any recurring decimal we have to put it if this number after one digit we can put it over 9. So this will be 6 over 9. In the simplest form 2 over 3. So this fraction 1.34 we can write this as 134 over 100 and simplify. So this will be fraction also. This fraction 0.75 in the simplest form 75 over 100 as 3 over 4. This also fraction. So anything we can convert it to fraction will be rational number. But the irrational number, anything has no square root and also has no cubic root. So this number has no square root. Why? Because the square root of 2, if you make it in your calculator, it will be 1.4 or something. So this will be decimal, but infinite decimal. Root 50 will be 5 root 2, or yes, 5 root 2 in the simplest form. If you make it, you will have decimal, but infinite decimal. If you have any infinite decimal with this, like pi is 22 over 7, it means 22 divided by 7 mean 3.14, and many digits after this mean infinite decimal. So this also a rational number. The same. The square root of 0, don't say for me this 4 has a square root. 0.4 mean 4 over 10. 4, yes, has a square root, but 10 has no square root. So this also rational number. So any number has no square root, mean no result, like 2 is nothing. Give me a square root of 2 mean 1 point something. This is not whole number. So this is not rational, this is irrational. So anything has no square root, has no cubic root, or any number with infinite decimal, this means irrational number. So rational number is a number that can be written as a fraction or ratio. A rational number can be written as fraction ratio. Like pi here, I told you this 3.1415 and so on, meaning digits, and we can make many things like this example, another example. If we found dots mean infinite, this means no end, so this is irrational. Now this is the first example in your book, Alpha book. Find the sum and product of each pair of number in the table. So I have to start with this numbers 1 and 7 over 8 plus 2. So if I make the sum for this, the sum here 1 over 7 and 2 plus 2, this will be 3. 1 plus 2, 3. And this number is supposed to be like this. This finite, mean with end. So this is rational for me. And this also, we take this together and make it plus. So this will be as fraction. This root 16 is 4. 4 plus this number will be 30.4. And this also 3 over 4 plus root 36. Root 36 is 6. And this number will be as 1 and quarter. So 1 and quarter plus 6, so 7 point quarter means 7.25. 7 quarter means 7.25. Now the product here, if I multiply by 2, will be like this. If I multiply this by together, I'll give you this, and this give you, and 5 over 4 times root 6 give you this number. So we found the sum of two rational numbers in a rational number. The product of two rational numbers is a rational number. Now find the sum and product of negative 2.5 and root 21. Plot the sum and product on the number line. So we start with first, negative 2.5 is a rational number. It can be written as negative 5 over 2. This one in the simplest form. Root 21 is a rational number. We can't written this as a fraction. So if we write it like this, we will have number without end, because there's no end for this. I told this before. So this will be a rational number. If I make it in the simplest form, or if I multiply it here, I found negative 2 will be infinite decimal like this. So this is irrational also. So you can approximate the location, make it close as you can round of rational number on a number line like this to make it something easy like this. Negative 11.45 by make it close to the nearest tenth, so will be negative 11.5. And this also we can make it close, also will be as you can to the nearest tenth, 2.1, negative 2.1, or we can make it as negative 2, the close. Both of them are correct. So we put it like this on the number line. Now simplify the radical expression. This radical expression I need to simplify. I told you before, 45, I have here to cut it, separate it to two numbers. One of them has a square root. 45 is 9 times 5. So 9 has a square root and 5 no square root. So 5 is still down of your square root. So this will be as this form 335. 335. This will be 335. So this one will become what? 3 and 3 has a square root, become 3. So there will be 3 root 5 because there's no square root here. So 3 is less twice, so we can move it like this. 45 is simplified, will be 3 root 5 finally. The other example, we can multiply together, then I simplify, maybe I can simplify, then multiply. We have many options. So I multiply it first together, so we put one root, then I multiply this together, 2 times 24 is 48. Then I try to find something has perfect square or square root, so I have to cut this to become perfect square. So 48, we can cut it to 16 times 3. So 16 times 3 give me 48. 16 has a square root, is 4. And 3 has no square root, so the answer will be 4 root 3. So 16 times 3. So I cut this and make this square root of 16 is 4 and 3 still down square root because no square root. So my result will be 4 root 3. We took this before. The area of a square is 2 square units. What's the perimeter of the square? The area of a square is side times side. So side times side, something times something, give me 2. So you found this root 2 times root 2. So we have two things repeated. If we multiply together, give me the 2, because the area of a square, side times side. So to find the side, we take the square root of the area. So the square root of 2, nothing. So area is s square. So 2 equal s square. I told you before, if I want to make this as s, we have to get rid of the power 2. So we have to take the square root. So the square root of s square is s, and the square root of 2 will be root 2. So this is my result. Then I need to find the perimeter of the square. The perimeter side times 4. The side times 4. Side times 4. So 4 times root 2 is 4 root 2. So this is your perimeter now. Now we're going to fill this things. I have to this value of 1296 is 36. I can make it with calculator. I can use this table and estimate, try to see this whole number. So here I have to choose this one or this one. Give me this number. I think this big number, because all of us know 12 times 12 is 144. So the square root of 144 12. So we have to try with this one. So 36. You have to check 36 times 36, or take the square root with calculator with this number, give you 36. So it can be expressed as a fraction. Yes, it is an rational number because it has a square root. I told you if you have a square root for something like this answer will be a rational number, or this number is a rational number. The value of pi approximated is 3.14. Is rational? Yes. Can't express as a fraction, so this is rational because this infinite decimal pi. If you remember 3.1415, many things. So we're going now to the value of root 144. Yes, you remember we just talking about this from a few seconds. So this will be 12 and can express as a fraction, and this rational number. We can divide this number by this number. Make long division and try to find. But here is approximately, so this mean is no final answer, no whole answer. So we can expect we have a decimal here. So this might expect number from here. So we can find this is something can express because it's finite decimal. So this is your answer. So we without any approximate here. So we have here rational number. The value of root 19 approximately is about 4.36, but this can't express as a fraction because if you make it in your calculator, you found your all screen full with your numbers. If you make it as a long division, you found you can't end this long division, will be dots, mean without end. So this mean is a rational number. Now we really estimate the value of 24 again, second time, and we want to simplify this as we can to make it as a perfect square. So we make it as root 16. The value is root 16 is 4. So to plot root 24, find the next perfect square, mean something before 24 and has a square root, mean root 16. Because after 24, root 24 is root 25. So we have something has square root before. if you want to dealing with something like this, you have to dealing with something like the square, like 2 times 2, 4. 4 is perfect square. 3 times 3, 9. 9 is perfect square. And 4 times 4, 16. This is your perfect square. And 5 times 5, 25. So you found this before 25. So I have to take something before 25 has a square root like 16. To find the next perfect square, next, we just said from few seconds. So this root 24 after this and has a square root, so this means root 25, and the value will be 5. So this number coming between two whole numbers, 4 and 5. So this number is supposed to be 4 point something, because this number root 24 coming between 4 and 5, so supposed to be root, and this number is very, very close to 5 or 25, so this will be more than the half, maybe 4.6, 4.7. So if you found your number, the original number is very close to the next number, mean you will be after the midpoint or the half of this number, so you can estimate it. Okay, so now we're going to this, your place is about 4.8, 4.9, 4.7, something like this. Okay, now we dealing with main example. Practice states the sum is the sum or product is rational, irrational. We have to decide, so we have to make this 3 over 4. This rational or rational? Yes, this rational, because has end. This is 0.75, no more, just 0.75. If we make it plus, we have also rational number, so the answer will be rational number, because my answer will be 6.35, finite decimal, so this will be rational number. 4.2, this recurring, but I told you the recurring is rational, so rational and rational also, so the answer will be rational. So the answer here will be 12.12, recurring here with 2, so will be rational also. This number and this number, we can make it together. This, we can simplify this as 5, this will be 5, and this will be, I told you from few minutes, this 45 is 3 times 5, right? So the square root for this is 3 root 5. But this number is not rational, is irrational. So irrational plus rational is irrational. So the number will be approximately 11.71. The other one, recurring, this means rational. This has a square root, so this also rational. So my answer is supposed to be rational. So if we make this as 5, so 5 plus 99 will be 104.8 recurring. So this rational. Recurring has no square root, mean irrational number. So irrational times rational will be irrational. If we found irrational, with adding, with multiplying, the result supposed to be irrational also, because it's impossible you have irrational in your answer. So the answer, the final answer will be also rational. So half root 7. Root 7 is irrational. Time is half, so the result is irrational also, and approximately will be 1.32. So we have multi choices here. Which product is an irrational number? So you have to decide by looking to these choices, or you can make it as you mentally or your calculator, but try to find 32 over 33. This rational, this fraction, so this rational, and this also 6.3, this also rational, so this give you the rational. So I try to find, give me something not rational, like this, root 11, root 13, like this. Root 13 has no square root, so this is irrational. Irrational times anything irrational. So my best choice here, this number, because this has irrational number, something with no square root. Which product is rational number? So I have to see something, everything as a rational times rational, irrational plus rational. In this case, we're dealing with product, so something times something give me rational number, so rational and rational. So the square root of 44 is no square root here, so this is not correct. So 25, root 25, so this 5 times 630, so this rational and this also rational, multiply together, give me rational. So this my best choice or correct choice. The sum is irrational number, so this irrational. So this is this rational because fraction. This rational, so give me rational. I need a rational. I found here dots here, points here. So this dots mean no end, mean this finite decimal. So the finite decimal mean irrational. So irrational plus rational give me irrational. So this my best choice. Which irrational number would plot slightly to right of 6 and number line. 6 right of 6. So I have to find something before and after these numbers and have something right of 6 mean your left will be 6 or mean under the square root 36. So I found this is before this after 36, so the before number will be 36. So this 36, so 6 point something. So this your answer, because the number has perfect square before 37, it's 36. So this is the correct answer for you. This. Thank you for watching. Your homework will be page 171 and 172. Make your homework. Escape this part. I'm sorry I didn't change it. I will escape it as I can. But this part from 8 to 12 doesn't matter. Try to dealing with 17 as you can, and you will see inshallah your homework. But send your homework in your classroom or my